In modern times, fossil fuels are an essential component of day-to-day life.
They turn on lights, they cook food,
and transport us to and from work every day. Though fossil fuels carry out necessary processes to maintain a high standard of living, not every outcome of using fossil fuels is beneficial. Burning fossil fuels emits carbon dioxide, the most emitted gas from humans in our atmosphere. Excess carbon dioxide in our atmosphere causes a variety of environmental issues, including global warming and sea level rise. By utilizing carbon capture and utilization techniques, engineers are able to collect otherwise wasted carbon and recycle it into other products. This promotes sustainability, economic growth, and the storage of renewable energy. Carbon capture and utilization, or CCU, technology will become necessary for reducing the amount of carbon in our atmosphere. I'm here to explain to you why we need CCU technology and what it could mean for our future. Though CCU techniques are a new technology, carbon emissions have been a growing problem for years. The first step to reducing our carbon output would be to become more energy efficient. This may include using cleaner energies or using less fossil fuels. In a study conducted by the U.S. Department of Energy, 83% of U.S. global warming emissions comes from energy-related carbon. Out of that, 39% is related to power plants, and 33% comes from transportation. In the 41 years between 1960 and 2001, carbon emissions almost doubled. This is due to the use of coal, which is used in electricity, natural gas, which is used for cooking, and oil, which is mainly used in transportation. Hopefully the popularity of carbon capture will continue to gain momentum as the 21st century progresses, ridding our atmosphere of excess carbon. Carbon capture works to prevent carbon from entering the environment in the first place. Carbon can be captured in three ways: pre-combustion, which occurs before the fuel is burned, post-combustion, which occurs after the fuel is burned, and oxy-fuel combustion, where the fuel is burned in the presence of pure oxygen. Once carbon is captured, it is compressed in order to ease transportation. It can either be sequestered, which means hidden away, or recycled into other products. Carbon sequestration is currently one of the top engineering challenges, as engineers work to improve its availability. Sequestration is beneficial because it prevents carbon from interacting with our environment. It also is stored where it does not disturb human activities, such as saline aquifers or depleted hydrocarbon reservoirs. Though sequestration is useful, it would be more sustainable to use the carbon instead of simply storing it out of sight. We are now able to utilize captured carbon to improve hydrocarbon recovery by injecting it into current oil reservoirs. This is called enhanced oil recovery. Other possible uses for carbon include in the production of algae, in the making of concrete, using it for liquid fuels, and enhanced coal bed methane recovery. Though all these uses are beneficial, industries view EOR as the most economically promising, as it is used to produce more fuel. In the present and moving forward, we must focus on capturing carbon that is emitted from industrial flues before it enters our environment and using that captured carbon to produce more fuel. Doing that, along with turning to renewable alternatives and using less fossil fuels, will allow us to reduce our output of the Earth's most common greenhouse gas, allowing us to make a healthy planet now and for decades to come.